cosmos that have an impact.
There are many independent measurements that build to our particular worldview at some time. So, for example, when you talk about the age of things, the age of the Earth, the accurate measurements come from, one thing is they come from radioactive dating, which is a very high precision technique to date rocks. And we can date the oldest rocks on the Earth, and we can date the oldest meteorites, and we can do those things. And we always get, for the oldest things, around 4 billion years or so, and you can hone it in from there. Then you can look at the sun, and you can say, well, we can do something called helioseismology, which is really like looking at solar earthquakes, if you like, solar quakes, and looking at the way the sun oscillates and rings. And you can use that to measure the amount of helium as a cross section through the sun. So we know that the sun shines by making hydrogen into helium in its core, which would suggest that there should be more helium in its core. And we know how bright the sun is, we know how much energy comes out, so we know the rate of nuclear reactions that we need to produce that amount of energy. So we can look and see how much helium's there, and that tells us how old the sun is. And you get the answer, which is about 4.7 billion years or so. So from a completely different measurement, you get a measurement that's consistent with the age of the Earth. So you build up this picture, in this sense, cosmology, from many different measurements, and they all appear consistent. So then you judge, if you make a measurement that jars with that whole lot, then it gives you a sense of that makes you perhaps suspicious. If it contradicts the whole swathe of other experiments, let's say we found out, well, actually, I'll give you a very good example. Which is that in the 1990s, we had a measurement of the age of the universe, which at the time, based on the expansion rate we've measured, was about 11.5 billion years. And we had a measurement of the age of systems called globular clusters, which are old star clusters in the Milky Way galaxy. And the age of those was about 12 billion years. So the age of the universe was measured to be younger than the oldest objects in the universe. And that was the case in the 1990s. So what did people do? They just carried on measuring things. And then in 1998, a physicist who's now at ANU in Canberra in Australia, Brian Schmidt, and another team in America were looking at supernova explosions in the distant universe and found out that they were dimmer than expected. And it turned out the interpretation was that the universe is accelerating in its expansion. A complete shock. It's like we thought the universe was slowing down. It turned it was speeding up. And that changed our measurement of the age to 13.8 billion years.